Right. So I just pick up from where we left off last time. So we had designed our database by identifying entities, and also we had looked at the properties for those entities, and we also discussed the issue to do with types, giving appropriate data types to appropriate field names, so that now we're able to have the first layer of protection as far as our database is concerned. So that is where we left it. So we identified all our entities and data types and the properties, and probably maybe the next thing that was left for us to do was to define relationships. So that's what I want us to do today. I want us to physically design or implement the database so that we're able to see how each and every part moves together. So I'll create a new database here. So I'm using SQLYog. You can really use any SQL database you want. In my case, I'm using mySQL. I have mySQL installed inside my system. So if you come to localhost over here, I have XAMPP installed, and XAMPP comes with mySQL and PHP. So it helps us a lot when it comes to that. Now, these people who are coming late sometimes, I don't like being interrupted once the class has started. So I just do this one more time. Just make sure you come early enough so that you don't interfere with the rest as we're going on. So as I was saying, XAMPP comes with MySQL. So MySQL and MariaDB are more or less the same thing. MySQL was bought by Oracle, hence it's no longer source code. So the community forked the code and formed what you call MariaDB, which more or less is MySQL on the open source side of things. So if you don't have the SQL agent like me and you have installed XAMPP, you can just come to localhost, then you come to phpMyAdmin. So this phpMyAdmin over here will allow you to be able to still manage your database as far as MariaDB or MySQL is concerned. So very important to note that it's a tool that's available for us, though I prefer to use other commercial tools like SQLYog, which makes it much easier for me to be able to create things like tables and all that. So you can see this is a UI and for MySQL, and this is also a user interface for MySQL. The only thing is that this is a bit more commercial. It's it is based on Windows, so it's running as an app installed on my computer. This other one is running on the browser, so maybe the experiences might not be exactly the same, but they still get the job done. So as I create the database, you'll be able to see that also I'm able to see the changes that I make across this other side over here. So I'll create my database. So when I'm here, I can come to the root here, right click and say create database. That's when I can create it. Or if I'm using this other interface, I can come here and say new, then I create the database name. I can call it hospital. Let me just call it hospital like that. So create. So once I create it like that, you can see it's asking me for a table, and by default it's giving me 4 columns. So when I come this other side and I refresh, I can click this to refresh. You can see I have my database over here. So depending on the user interface you prefer to use, either would still be able to work out. So once we create the database, the next thing to do is to create tables. Now, what tables did we say we have? What entities do we have? Entity one is, these people are coming in right now. I don't like this, eh? Now, the entities that we have, what were they? Then I can close this other one so that our user interface looks nice and clean. I think that's better. So what entities did we define? We defined the patients, right?
Patient.
So let's create them one by one.
Specialist.
Let's create them one by one. Patient. So when it comes to patient, we have patient ID, which is going to be integer or number, and it's going to be our primary key, and it's going to be auto increment. Okay, so patient ID is an integer, which means it's a number, whole number. It's a primary key, which means it's unique. It is not null because it is auto-increment. So it starts from 1, 2, 3, 4, and it's going to continue like that until infinity. Well, technically, we can't have infinity on database because it means a lot of data, but it can go on and on, right? Then we have the first name. Actually, we can start with the patient number. We have first name, middle name, last name, gender, date of birth, blood group. Now, this one I'm going to make it a number because blood groups are very specific. Well, can we have, I think we can just have blood group because we are not going to create any new form of blood group, isn't it? Then we have their mobile number, email address, we have their residence. What other information did we need to capture about the patient? While we're doing that, we can define this. This will be variable character, 15 length. It's more like a string. Sorry. So that will be that. That will also be that. That will be that. That will be that. That will be that. That will be date. Blood group will be that. Mobile, we expect it to be numbers, so I can put integer. Email address will be that. And of course, residence will be, I can put 100 for this. Do we need,
Nationality.
Go ahead.
Nationality.
Nationality. So we have nationality. Let's just say country ID. This is going to be integer because you're going to have a list of countries, so that now we are able to link them together, isn't it?
Yes.
So this is
Next
special.
of kin.
What else?
Next of kin.
Next of kin. So
ID and name.
okay, name. By the way, we can okay name and okay mobile and okay email and okay relationship ID, something like that, right? So next of kin name will be variable character 50. Mobile can be integer. Email will be variable character or string 50. Relationship will also be integer. So that's our patient, isn't it? Then what we can do is this patient has to be created by user. So we can say added by, which is going to be an integer. Then you also have date added. Then we can have something like the platform that was used. Maybe it's a mobile device on Windows, on browser, which is Chrome, something like that. So maybe when we're doing our audit trail, probably maybe not have this here, but probably you can have it on the audit trail. But date added and added by is okay. Then you also have status. Now this status can be either they are active or inactive. So instead of using that, we can use enumeration, and you can say they are either active or inactive, or any other status that you might want to have over there, something like that. Okay. So of course the status should come before added by and all that. So I think this is not everything, but this is good enough. Okay. So you can start with that and save this. So once you have saved this, it will ask us, do you want to create another table? I'll say yes, because I need to have countries so that I match the countries. I also need to have users so that I match them with users. So I'll say yes. Then we admit these others. Please, next time you come late, I'll not admit you. So, okay. So we have created a patient. We can create countries, not country, but countries, like that. So we have country ID, which is integer, primary key, auto increment, country name, dialing code, this is integer. Then we have default. This is going to be Boolean, which is true or false, but by default I'm going to make it false. So by default, the country is not going to be the default. Only one country can be a default. Okay, so I'll save that. So I still need to create another table, which is users of my system. This one should have been patients, countries. Then I can come to users. So users, I have user ID, which is integer, which is primary key auto increment. So you'll realize that for every table, I have an ID field which is integer and auto increment. That's also my primary key. So it means that that's going to be what I'm using to form relationships all over the place. It's a good practice. So I also have username, what they're going to be typing when they're logging in. So like that. I have their first name, middle name, and last name. So that's going to be that. That's going to be that. And also that's going to be that. So once I have that, I need to also save a password for them. So the password will be variable character. I'll give this 100 because I'm expecting it to be longer. Then I have something called a salt. I'll explain what a salt is. It's going to be 50 characters long. I'll have status, which is going to be an enumeration, and it can be active or inactive. Then also I can have change password on logon, which means when I create this account, default will be 0. I can set a password for the user, then I expect them to change the password once they log in. I also have a flag called system administrator, which is Boolean. By default, it's also going to be 0. Then you can set the accounts to expire. Since this is going to be a delicate system and you can have interns, you can set account expiry date. So account expiry date. First of all, you can set by account expires. Account expires. That's Boolean. By default, it's not. Then account expiry date. So if you say account expires, then account expiry date, which is going to be the date when the account expires. Okay. Then now the only other thing we would probably have here is their mobile and email address. So mobile will be integer, email address would be variable character 50 in length. Then of course we'll be have added by, worded, date added, deactivated by, date deactivated, and deactivated reason why it was deactivated. So this is variable character can be 1000. Deactivated will be date and time. Deactivated by will be a user. Added by will be date and time, so timestamp. By the way, you can use timestamp here, it's allowed. Timestamp. This one will create for you this day, it will create the insertion date and time. But because I like control over that, I'll simply use date and time so that I can control that. Then added by will be integer like that. So this is our user, and you can see it has so many fields. Now salt, what happens is when you store password, we don't want even the admin to be able to read your password or reverse engineer your password. So a portion of the password will be stored in the database, a portion of the password will be with the user. So when you combine the two of them and you encrypt them, then they will form this password over here. I'm going to show you how that works out, just bear in mind. So I'll save that. Do I need to create any other tables? Yes. So I have patients, I have countries, I have users. So if I look at patient, any other relationship I need to have over here, there is no other. So I think this is practically fine. So for blood group, instead of varchar, we can use an enumeration because we have blood group. Which one do we have? A? Is it A or A positive?
AB positive, A positive.
Let's do this. I'm not very familiar with that. So let's use Google blood groups. Yeah, there's A. Okay. Okay. 8 common. So there is O positive, O negative. So I'll put them side by side here. These people are coming as late as 1 hour. What do they expect? I don't like this at all. We need to respect time. Time is very, very key. Time is very, very key. And when you're coming into the meeting, come with the mic. Come with your mic muted, please. All right. So we have O negative, O positive. What else was there? A plus, A minus, B plus, B minus. So we have A plus, A minus, B plus, then we have AB plus and AB minus. So there is AB plus and AB minus. So this is how you design database. So it will only be able to accept only the values that I've listed here, nothing more than that. Okay, so we have that. Then after patient, what else did we? Still on patients, we had allergies, right? So we can say we need to create a table here called allergies. Allergies like that. And I'm using lowercase because I intend to use PHP, which is a case-sensitive language, and as such, title cases are going to give me a problem. So that's why you realize that most of the time I'm using lowercase letters to make it easier for me to be able to not make mistakes when I'm typing my code, and I don't have to be very specific on how the column names are labeled. If all of them are in lowercase, it makes it much, much easier for me. Okay, so that's the reason why I'm using lowercase in everything. So you can see all my columns are actually in all lowercase. So allergies, we have allergy ID. So that's primary key auto increment. We have allergy name. That's going to be maybe 1,000 or 100. So description, you can describe the allergy. What is it? So again, this one you can use text because you want it to be as many text as possible. So you can have date added by status is either active or inactive. Or instead of doing that, you can just say deleted. This is going to be Boolean. By default, it's not. It's no. So get deleted by, and reason deleted. So you realize that these last fields are going to be very common. These last 7 fields are going to be common almost in all the tables that we're going to have. So we have allergies. So once we have allergies, we can get another table and we can call it patient allergies. So I have a patient, I have allergies, then I need to link patients and their allergies. So this patient has these allergies, so something of the sort, so that if I wanted to know how many patients are allergic to beef, or they have lactose intolerance, or whatever it is, I can be able to count very easily using the allergies table. So I just do a join with the allergies table and I'm good to go. So here again, I'm going to have a patient allergy ID. That's going to be integer, primary key, auto increment. So I'll have allergy ID, which is integer. I also have patient ID, which is integer. Then I can have narration. I can narrate what the allergy is all about. Probably if they take egg, they, whatever happens to them, something of the sort. So I can use 1,000 here. Then I can have it added, when of the allergy added, who added it. Then I can have added by, should be added by, then data type added by int, then deleted, it's going to be boolean, default is going to be 0, date deleted, the date and time, deleted by is going to be integer, and reason deleted is going to be reason deleted will be variable character 1,000, something of that sort. And I can continue to add more and more and more tables. Like, for example, I can go on and add, we also talked about diseases, right? So we have disease ID, disease name, description. This is going to be text. This is going to be integer. Primary key, auto increment, is going to be variable character 50. Then this is going to be date added, added by, deleted, it's going to be boolean, default is going to be 0, deleted by, it's going to be integer, a user, date deleted, it's going to be date time, and of course reason deleted, it's going to be variable character 1,000. So you can see how I'm going. So I can go on and create as many tables as I possibly would like to have. Okay, so this is very important. I want you to create all the entities that we had defined with all their fields and data. This is what I wanted to show you. This is how it works out. So of course you're going to go to the next step, which is how do we create the relationship. But of course I have done 1, 2, 3, 4, 5. I think these are about 6 tables. We have about 30. So you need to create all the tables with all the fields and all the data types. Then you go to the next level, where now we're going to come and create the relationships within the databases themselves. So now there are 2 ways you can create relationship using the tool I have over here. Of course, I like the easy way, where I can come to patients here and I come to foreign keys here. So I have columns, which is default, by default where I'm creating my columns. Then I have foreign keys here. So from the foreign keys, I can say the column I'm referencing here is probably say country ID. So this country ID, I want to reference the countries table, and as you can see, automatically it will pick country because those two fields have the same data type. So all of them are integer, and this is the primary key. So because all of them are integer and this is primary key, automatically it detects for me. Otherwise, if it was not able to detect, I would need to come here, then I pick the column by myself. But if you design it properly, it more or less would be able to pick it automatically. So that's one. I can come and have another reference here. Do I have any other references? I have a reference here called user added by. Added by is going to refer to a user, and you can see it gives me user ID. Same with deleted by. So I don't have deleted by here, so that's fine. I'll just leave it at that. So let's assume I have these two and I save. That's one way of adding relationship. Now, what's important is these two columns at the end here. So what do you want to happen when the parent row is updated? So maybe the country ID is updated from 1 to 30. What do you want to do? You can take no action, you can cascade, or you can restrict, or you can set it to null. Cascade means if the country ID changes from 1 to 10, go to the table where I have the patient, where the ID is 1, change them to 10, what has been changed. So that is what cascade means. No action means leave it as it is, but then that could create what we call orphan records, and that's a problem. Restrict means don't allow that to change, and of course set null means whenever that changes, you set the ID that was referenced to null. So by default, it is cascading, so I'll leave it at that. On delete, you can also provide the same thing. When I delete the parent record, what do I do with the children record? So if I delete country ID number 10 and I have 10 patients who are belong to country number 10, what do I do? By default, I want to restrict. Okay, I don't want to cascade. So I will restrict, which means that I cannot be able to delete a country if there are, actually the default is usually restrict, which means that I can't be able to make those changes when parent records are there. So we don't want to have what we call orphan records. So on update and delete, you can leave them default, which means they're on restrict. So ideally, whenever you want to change a country's ID, if there are any people with that particular country and the ID you're trying to change does not exist, then it will refuse. Okay, so I'll demonstrate that when we are doing that so that you're seeing how that happens. So that is one way of creating relationships. Now, so that's one. So the other relationships that I have are inside allergies here. Remember, allergies, of course, countries can also be added by a user. You can have users adding countries. So date added, the time added by integer, deleted is boolean. By default, it's 0. Date deleted, date time deleted by is integer. Reason deleted is varchar 100. So when I have this, I can come to foreign keys here. Then I'll pick here added by. Then I reference it to users table. Then I can pick here deleted by, also reference to users table, because it's only a user who adds or delete. So you can see that. And then of course I'll save that. Automatically it will create for me the constraints name, as you can see over here, and of course the cascades and all the updates and delete cascades will be restricted by default. So that is one of the ways that you can be able to create relationships. Okay, and that is the easiest way for me anyway. So I just got the foreign keys field, and from the foreign keys field, I am able to drag and drop, and I'm good to go. Now, if you're using something like PHP MyAdmin on this other hand, so let me just come here and refresh this, and you'll be able to see I have all my tables here as I have created them on the other side. So if I wanted to create relationships, I would probably come to I'll pick a database like hospital here. This top menu will change a bit. Usually it's a bit slower. So I'll come to designer over here. So once I have designer over here, then by default, you can see my relationship are my relationships mostly. Some of them are already in place. I don't like this sometimes because it plays sometimes it's usually a a not so pleasant experience. Dragging and dropping sometimes becomes a bit of an issue with it. As you can see, that's why I don't like this user interface. But what you needed to do is okay, let me let it settle. Let me just refresh that. So once I have this relationship like this, what I could do is to say I have patients here and I have patient allergy here. So this patient ID references this patient ID here. So what I can do is I can drag this one. I'm seeing it's not even allowing me to drag and drop. I can drag this one and come and drop it inside here. Well, I dropped it wrongly, so that's why I was telling you I don't like this UI sometimes. It's not a very good experience. Sometimes it works, sometimes it doesn't work for you clearly. So sometimes that's why I prefer to use this other IDE. So if I wanted to attach patient to the allergies again, I'll come to allergies, foreign keys, added by would be users, deleted by would also be users. So you add them one by one. So users, like that. I'll save that. Then now I come to patient allergies, foreign keys. I'll pick this allergy ID. I'll pick this patient ID. I'll pick added by, and I'll pick deleted by. So allergy ID comes from the allergies table. Patient ID comes from the patients table. Added by comes from the users table. Deleted by comes from the users table, and I save that like that. So that helps me to create the relationship. Then I come to disease here. The same thing, foreign key. Then I pick added by, deleted by. This comes from users and users, and I save that like that. So that way you'll be able to see that I have created all the relationships for the current tables I have within my database. So inside the SQLYog here, if you want to use the SQLYog, simply come to relationships, which is this new schema diagram over here. Then right click and say add tables. Then you add all your tables like that. And what you realize, I know the users table should be at the center because it's the one that's connecting them all. So when I drag this and make it at the center like that, you'll be able to see all the relationships that we have set up. So you can see that, right? And of course, it tells you the type of relationship that is there. Whenever you see an infinity, it means one record here relates to many records here. So one user can create many diseases. One patient can have many allergies. So one patient can have many allergies, and of course, one allergy can be applied to as many patients as possible. So that's how you create the relationship. So one means one record here relates to many records here. One record here relates to many records here. One record here relates to many records here. One record here relates to many records here, and so forth and so forth. So you can be able to see this is what we are calling an ERD, or an entity relationship diagram. So it tells you how your entities are related. So this entity, this entity, this entity, this entity, this entity, and this is how the entities are related. So that's the next thing that you will need to do when you have created all your tables. Just come and try and visualize how the relationships within your entities are. And this is important because it means that I have protected the database from the word go. One, I have identified the entities. Two, I've identified the properties or attributes, and I've given them the appropriate data type. So somebody cannot be able to put wrong type of data in a given column. Then number three, I have enforced relationships. So that way, it means that I cannot have orphan records. So if I need a record to come from one table to relate to another, then that record must exist before the entry is actually made. And of course, I'm going to demonstrate that within our next class so that you see how that works out. Any question up to this point? So that's very, very important. How exactly do we implement the database design that we did? This is exactly how we implement it. Kuna swali mpaka hapo? I had the people who wanted to join. I don't know why they want to join when the class is almost over. Well, we still have another 45 minutes, but that's okay. Okay, I'll admit them. I'll admit them anyway. But just so you know, it's very bad manners to come late.
Excuse me, sir.
Go ahead.
Yeah, I wanted to ask about the process where you connect the XAMPP and the SQL so that you can be able to form the table. You had mentioned it earlier, but I didn't get it.
When you install XAMPP, by default, it installs something called phpMyAdmin. So I'll just come back to this. When you install XAMPP, it comes with phpMyAdmin as default. So what you do is open a browser window, then just open localhost like that. Once you open localhost, click on phpMyAdmin at the top here. So it will give you access to the MariaDB or MySQL database. Okay, so from here, you can create a new database, you can open your database, you can create new tables. By the way, even from here, you can create a new table by simply saying new table. It'll ask you, you can see it's a bit slower compared to the user interface. It'll ask you to pick the column names, pick the data types, pick the length, the default value, collection, you can leave default attributes. Is it a nullable field? Is it auto increment? Yeah, so you can see it has some more fields that I have on my other side, but most of them are not really important. The name, the data type, the length, default value, null, whether it's nullable or not, auto increment. Those are the ones that are very, very important. Once you define those ones, you can just go ahead and save your table. Okay, maybe probably I can create one from here so that you see how that works out. But though I hope I have answered your question.
Yes.
Okay, so which other entity did we have? We had an entity called doctors, right? Or we call them specialists. Did you call them specialists or doctors? Remind me.
Specialist.
Okay, so let's put specialist over here. So I'll disregard this one. I'll come to my tables here. I've picked the wrong database that has too many tables. Don't worry about that. So I have my database over here, so I'll click on it. Then if I wanted to create a new table, what do? I come here and say create table. Then I give the table a name. So this table is going to be called specialists, like that. Okay, so either you click on this, or when you're at tables, you say create a new table, then you specify how many columns it has. Specialists can have maybe say like, let's start with 4 columns because you can always add. So we have specialists. So we have specialist ID, that is integer. Integer, it is auto increment, and of course the index is that it's a primary key. Okay, so you can see the interface is slightly different but more or less the same. Then we have first name, which is variable character 15 length. Then we have middle name. You can see this one is not very comfortable to work with, variable character 50. We have last name, variable character 50. Then again, I can add more rows if I need to. So there was here a number of that's column. I want to add another 3 columns. I'll say go. It will add 3 as you can see down here. So I have gender, which is enum. Enumeration, do we have it? They're supposed to be organized. I have enum here, and the enum I'll set the values into male. You can see now this one makes it a little bit more difficult for me to be able to provide that again. So after gender, I'll have mobile, then I'll have email. So again, mobile is integer, that's okay. Email address is variable character, which is 50, and I can go on and on. So I will save this from here by clicking on save. It will create the specialist over here. So when I come here, I can make the modification. So when I come here and I refresh, you'll see I have my specialist. So in short, I'm trying to say you can use different user interfaces. All of them are going to access MySQL in the background, and they're going to allow you to be able to play around with it. So to make changes to a table, you just right click and you say alter. So I'll have this. So now I can go ahead and now make the other fields, add the other fields. You can see this one is a little bit neater in terms of look and feel. It's more polished, so to speak. So the other fields I didn't have here, like for example, doctors can have multiple specializations. So I have that. So I can have title. They could be a professor. Title could be integer. So I can have another table here for titles. So title ID, title name, date added, added by, deleted, date deleted, deleted by, this one deleted. So this one will be integer, primary key auto increment. This one will be variable character 15 length. So it's something like Dr., Mr., Mrs., Professor, whatever it is. Okay, so they have different sergeants all together. So the date added is date and time, added by is integer, deleted is boolean, default is 0. Date deleted is date time, deleted by is integer. Reason deleted is variable character, probably maybe give it 1,000 characters. We're assuming you're not going to provide more than that. Then, besides the titles, we also have specializations. So we have the specialist and we have the specializations. So specializations are the various fields that are there. So we have specialization ID. Specialization ID. Specialization description. So if I say somebody is a neurosurgeon, I can describe what a neurosurgeon does. Date added, added by, deleted, deleted, date deleted, and deleted by, and reason deleted. So again, specialization ID, that's integer, auto increment, primary key. Specialization, that is variable character, 50. Here I might want to describe in detail what they do, so I put text. Date added should be date time or timestamp. Added by is integer. Deleted by is integer. Deleted is boolean, but the boolean is just integer of 1 digit. By default is 0. So even when you put deleted as boolean, next time you come to edit it, you'll see it's tiny integer, which means it's an integer that has 1 digit. So we can either put 1 or 0. So you can still say tiny int here, which is what it's going to give it. Tiny int, this one. You can put tiny int, and boolean would do more or less the same. So if I put boolean, by default you'll see it converts it into a tiny integer. Then deleted is date time. Deleted by is integer. Reason deleted is variable character 50. Sorry. So once I save this one, I can come back to my specialist and say the title, the specialization ID, So we need to know what they're specialized in. Are they a general practitioner? Are they a neurosurgeon? Are they a dietitian or whatever it is? Are they an they're called oncologists, those people who deal with the colon and cancer and all that kind of stuff. So you can be able to specify the specializations from here. Then you link them, you link a specialist with a specialization. So if I want to know how many neurosurgeons I have, I can simply, using this ID, come to the specialization table and combine them together so that I'm able to count very, very easily. Any other field that we have specified? By the way, they could be the type. They can either be permanent or a consultant. So that one can be enumerated, and you can say they are resident or they are consultants. So a specialist can be either a resident specialist, which means that they have been hired by the hospital, they work at the hospital 24/7, or they can be a consultant. They can only come on consultancy basis. So for example, people who do a neurosurgeon can be a consultant for Nairobi Hospital, Nairobi US Hospital, for Kenyatta and all that. So this is where they are employed, but then they consult for this hospital whenever there is a need, something of that sort. So I said resident, then the other one should have been consultant. I forgot to add that. Yeah, something like that. Then also you might want to say date added, date and time added by int. Have they been deleted? Boolean. Default is 0. Deleted. Date deleted. And deleted by. Then we have reason deleted. So you can see your database can grow within a very, very short time, and it becomes something extremely huge. So we have that. And again, so since I've added 3 tables, I need to add the relationship. So I'll come to foreign keys over here. I'll specify these specialists. There's this specialization. There is, by the way, there should be nationality. I need to know where they're coming from. So I can come here and I say country ID. Because they could be international, so that's very important. So I'll put country ID here. I'll put added by. I'll put specialization ID. Oh, that one I've already done. I'll say deleted by. So this specialization ID comes from specializations table. Then country ID comes from countries table. Added by comes from users table. That comes from users table. Then once I do that and I save it, it is able to create the relationships for me. Then I come to titles here. I forgot the title ID. So I can come here and say title ID. I just need to call it title ID. Usually anything that's an ID, you want to refer to it as such. So title ID. This comes from titles. So whether you're a doctor, you're a professor, whatever it is, you're Mr., Mrs., whatever title we give you, we'll do that. So I have that. So when I come to titles, again, foreign, this one is mostly added by and deleted by. And all these are coming from the users table, like that. Then I come and add the others, which is specialization. Again, foreign keys. So what happens here is just added by and deleted by. And all of these are coming from the users table, like that. So before you insert any data into your database, make sure you create all your tables, you define all the fields, then you give them appropriate data types, and then you enforce relationships. So when I come here, I'll say add tables, and I'll add the ones that are not there, which are these three, and I can just move them around here like that. So you can be able to see actually where is users. Users should be at the center. User should be at the center because all of it is one that connects all the other tables within your. It's the one that connects all the tables because somehow a record must be created or be deleted by a user. So you can see as I move along, it also becomes better and better. Okay, kuna swali mpaka hapo? Is there a question up to this point? I think silence means that we are in agreement. So that is good enough for me. Can we move to the next thing?
Test types.
Yes. Is there a question, or we move to the next thing?
The next thing is test types.
Test types. Yeah, those ones are just fields. So I want you to go ahead and create them. Those are just entities. So I want you to go and create all the other entities that are remaining. Then those entities that are remaining, you also form relationships. So I've shown you how to create 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've shown you 9. I think you're remaining with 21. So you can add the other 21, form all the relationships, then come to this schema view here and see how those relationships look like. This one more or less helps you to visualize how your data is related to one another. And that's very important because once you relate it properly, then it means that you will be good to go. So that is going to be your task. You're going to design, you're going to add all the other tables that are not there so that now we have all the tables within my database over here. So that is going to be your assignment. Now, the next thing I wanted us to do was to be able to see how we can now insert or do what we call CRUD operations as far as our database is concerned. And I'll use a very simple one like countries and titles. So because they have very few fields, I'll probably have that. Of course, I need to create a user first of all, so that now once I create this user, I am able to use that particular user to be able to insert data into my database. So let's see how now we can be able to populate data inside our databases. Remember, data is going to be populated from the user interface, but of course we need to write logic that tells the database how to insert that data. You can use straight SQL statements like insert to and all that kind of stuff, but I'm going to show you something that's much better, and it's called using stored procedures. So stored procedures, basically, they allow you to be able to have the database do its own functionality. A classic example is say I want to create one application and I want to have as many interfaces as possible. So maybe I have a mobile interface, I have a desktop interface, I have another API that connects to my database and all that. So I want to be able to control how data is going to be inserted into my database. I want to do validation. I want to perform some processes. Maybe if it is a number to be generated, I generate it, and all these kinds of stuff. So stored procedures will help me do that because it's basically SQL that is stored on the server, and it offers us multiple advantages. And one of the advantages is, as I've said, scalability. So if you want to use multiple channels to do the same job, a stored procedure would allow you to do that because it will contain all the logic that needs to be done. So the only thing you need to do is to call it and give it parameters. Once you give it parameters, it's able to do everything on its own. That's number one. scalability. Number 2 is caching. A stored procedure will create what we call an execution plan, which means that it knows what it's supposed to do in advance. It has indexes, it knows how to sort the data. So it will create basically an execution plan, and it knows that when I am called, then this is what I need to do. So it is much, much faster than just throwing a straight SQL statement. Number 3 is security. Stored procedures act or are executed by a user, and I can disable the user that can be able to access them. So in a nutshell, even if you have access to my database, I can decide whether the stored procedure can be executed or not. And of course, number 4 is it makes it very easy for you to debug your application, because now we're going to separate logic from how the database operations work. So you will see that when we are using stored procedure, they offer us so many advantages as opposed to writing raw SQL statements inside either our PHP or Node or Python or whatever it is backend language that you want to use. Stored procedure will give you a very neat way of doing it, makes it very clean, easy to debug, and all that. And of course, when it comes to scalability, I can come and make changes to it without compiling the program. So if I was doing a Python application or a desktop application, I can go ahead and make changes to the stored procedure in terms of logic and everything else, and I don't need to compile my program back to be able to correct that mistake or improve that feature. So it gives you very many advantages when it comes to using them. So I'm going to show us how to use them, then we'll see how that works out. Okay, so to do a stored procedure or to use stored procedure, one, if you're using an interface like SQLYog, like me over here, I could simply come to this plus at the end here, this plus, then I say new query editor here. Then I can type my stored procedure here. So it's something like create procedure. Then I give it a name, blah, blah, blah. I don't need to remember the syntax for that, so I'll just ignore that. So what I can do is I can come to my database here, then I come to stored procedures here, then I right click and I say create stored procedure. Then it will ask me the name of the stored procedure. I'll simply say SP for stored procedure, save user. I want to save a user, okay? So I'll create save user like that. So you can see it tells me create procedure, name of procedure, begin, end, the limit. So these comments here, I can remove them. These comments there, I can remove them. So it was supposed to look like that when I was trying to type it. So I didn't want to spend a lot of time memorizing this syntax. So it's much easier to just right click here and say create stored procedure, give it a name, then it creates one for you. So you can see it has created a new interface for me, a new query for me here, and then I can just be able to go ahead and type in. Now, stored procedures have what we call parameters, and parameters will allow us to be able to pass variables to that stored procedure. So let me say, for example, I'll not create user because it has so many fields. So what I'm going to do is I'm going to come to this users table and I'm going to open it. And I'm just going to create a user called admin. First name is system admin. The rest I'll leave blank, sorry. The rest I'll leave blank because this is my seed user. I need to have at least one user to be able to try this experiment. So when you're creating a user from the user interface, we're going to fill in all services, but I need this user so that when I try to add something like a title, I have a user who can create that title. That's why I've created the data manually. So what I'll do is, again, I'll come to titles here and I'll say I'll come here and say create procedure, and I'll say SP save title. Now save title, I'll remove these comments. These are comments, so I'll remove all the comments like that. Then I can make that one line like that. So when it comes to title, first I need the title ID, which is integer. And I'm using $sign because I'm expecting to use PHP, and PHP uses $sign for its variables. So that's why I'll use $sign. But you can use something like an underscore. I'll prefer to use this way so that I know this one is a variable and not necessarily a field name. So I prefer to use that. So I'll have title. So when I cut title ID, so when it comes to title ID, then I have title name. So I also need title name, which is variable character 50. I also need to know who added it. So added by. So I also need added by or user ID, which in this case is integer. Those are the three things I need. Give me the title ID, the title name, and the user ID. Why do I need the title ID? Because I want to use save title to do two things. I want to use it for insertion or update. If the title ID is 0, it means that I'm creating. If the title ID is not 0, it means I am updating. Okay, so if title ID is 0, insert a new record. If it is not 0, update where the title ID is similar to the title ID that was passed. That is a common practice. So what I'm going to do here is I'm going to say if title ID is equals to 0, then do this. Otherwise, do this, then end if. So you can see this allows me to even create logic, and this is something you can't do in normal raw SQL. So you can see even inside my database, I can still be able to implement logic. So if the title ID is 0, I'll say insert into this table called titles. You can just double click on it. Then I give it values. Then I close. So inside the titles, what am I inserting? I'm inserting the title name. I'm inserting date added. I'm inserting added by. Those are the three things I'm adding. So title name will be this title name over here, this variable. So I'll say title name. Added by, I'll use the current date and time, which is now. So MySQL will give me, when I say now, it will give me the current date and time. Added by will be this user ID that I passed here. Of course, by default, the data will be 0. The rest are going to be null as of that. So I'll put a semicolon. Now, if the title ID is not 0, then what I'll do is, and this is the beauty of this, I'll simply come and say update this titles table. Then I'll say set, the value I'm setting is title name only, is equals to title name. Then of course I need to specify my condition. You guys have done databases, so I'm assuming these are things you know, where title ID is equals to the title ID I specified up here. So this title ID. So if the title ID is not 0, update the titles, change the name to what I have provided, while the title ID is what I have provided. So maybe like I've picked the title and I've said edit, then I'm trying to make changes to it, something of the sort. Then I'll do that. So once I do that, of course, each and every statement has to be terminated with a semicolon. That is how SQL works. So this over here will actually allow me to be able to create a procedure that allows me to create titles and insert the data into my database. So what I'm going to do is I'm going to click on this execute all icons over here. And if I see an error here, it means a problem. So there is this title ID. So it's not title ID, it's supposed to be title ID. So I'll come and just check where I have made a mistake. Title ID. So it's not that, it is title, like that. So this is the spelling mistake, title ID. So you can see it tells me I have not declared a variable title ID. Again, execute it. I want to see here success. This is what I want to see, success with no errors. It means that it's executed, and if you come here, you can be able to see I have my stored procedure. Now, this is SQL that is stored in my database, and I just need to refer to it. So right now, you can see that I have no titles inside my database. There is absolutely none. So I want to create one. So what I'm going to do is I'm going to take the entire stored procedure here so that I can test it to see if it is working. I'll create a new window over here. Then I'll paste this. So to execute a stored procedure on MySQL, you simply say call. Then you set the stored procedure. Then title ID is 0 if I want to create a new one. Title name, let me say doctor. It's a string, so I'll say doctor. Then user ID is, let me put 0 so that you see how it works. Because I've enforced relationships, there is no user with ID 0 on my table. So you can see the ID I have is 1 going forward. So I don't have ID 0. So if I try to execute this, It's going to tell me cannot add or update raw child foreign key constraint. So there's this constraint that has failed, which is a user. So the user that I'm trying to use 0 does not exist. So the database will actually not insert that data. So if I try to refresh this, you can see the data has not been inserted. So what I'm going to do is instead of 0, I'm going to use 1 because I have a user ID 1 over here. So if that user is existing, then I execute this. You can see it's telling me now it was successful. And when I come to my table and I refresh, now I have doctor. Okay, I can create another category. I'll probably call it Mr. Execute. And when I come back to my database, you see it has inserted Mr. And I can have prof. And execute it. And if I come to my table and refresh it, you can see I have prof. So my point is I have created a stored procedure here, and I am able to execute it just by calling it and giving it the appropriate variables it requires. Then the stored procedure will do its own work internally. So if I wanted to edit from prof from Mr., like you can see here, I have doctor with an R. I want to remove the dot. You can see the title ID is 2. So what I can do here, I can say title ID is 2. Then this is going to be MR, like that. So it means that I want to update where the title ID is actually 2, something of the sort. So if I do that and I execute this, it is successful. And when I come here, you can see now it has a dot. I've put Mr. It's supposed to be doctor. So when I come here, it has a dot. When I refresh this, you can see now the dot is actually gone away. Okay. So this is very important. So this is what stored procedures do. They help you to write logic inside your database, and then you can actually be able to implement the database directly. Let me give you another nice way of how this would work. Now you can see, or rather why this is very important. You can see I already have doctor over here. What if I wanted to make sure that this doctor, you can't repeat it? Because what I will have here is, if I come here and say 0 here, and just say doctor again, it will add it. So when I come here, now I have 2 doctors. I have this doctor and I have this doctor. How do I control that, for example? Now this is where, and these are now the advantages of stored procedures, because I don't need to do validation on my front end to make sure that the database stays clean. I can actually implement that within the database itself. So what I'm going to do here is I'm going to close this so that I open it from here and I say alter. Then here, if you're trying to add a new one, or basically what I can do is I can come and say, first thing, check if this title that I'm trying to add exists in the database. If it exists in the database from some strange reasons, don't do anything. So I'll come here and say, if not exists, select all fields from titles where the title name is equals to the title name that are provided and it is not deleted. If that is the case, then do the following. Then otherwise, so what will happen here is this. So I just indent these ones. Sorry. I'll just indent. Okay, I don't know why it's refusing for me to indent these ones. So yeah, that's okay. So I'll move this one backwards. So what I'm trying to say is, so long as this statement returns a value, this will never execute. So that's what I'm saying, if not exist. So if this title does not exist inside this table, then go ahead and do this. If it exists, don't do anything. So what I'm going to do is I'll come and save this stored procedure again. I want to see success here. So success is actually there. Then I'll come back here. You can see initially I was able to add doctor. So let me try to add another doctor, execute. you can see 0 rows affected. And when I come here, no doctor has been added. Let me add Mrs. So I can come here and say Mrs. Then when I execute it, you can see 1 row has been affected. So it means Mrs. didn't exist inside that table. So it went ahead and I've created Mrs. So you can see how stored procedures come in very, very handy. So I don't need to do any validation on my front end for things like this. Maybe I want to check if this data exists because it's supposed to be unique before I add it and all this kind of stuff. Of course, I could make that column a unique constraint, which means that if somebody is trying to add double, it will throw an error. But sometimes I just want not to throw an error, but just do validation in such a way that now my application is a little bit smoother, and probably I'll be able to tell the user that, well, this title you're trying to add does exist, or things like that and stuff like that. So it will depend on really how you would like to your application to work. But in a nutshell, I'm just trying to explain. If you're going to use stored procedure, I'm not using any programming language here besides SQL, and you can still be able to see I am able to control what data goes into the database in a way that it goes into. So if it does not exist, then if it is the title is 0, then it can be able to insert it. Otherwise, it should be able to update it and all that kind of stuff. This is very complex logic. If you're to do it inside something like PHP or maybe even Ruby or Node.js or something like that, or even Python, it will be some very complicated logic to implement. But you see, if I'm going to use SQL, then it's going to be much, much easier. And as you can see, I can easily come and modify and add features to this application without necessarily affecting the front end or even compiling it from the other hand. And the good thing is that, as I've said, once you run this query for the first time, the database engine will create an execution plan, so it knows what this query does and prepares in advance. So every time you execute that query, it runs more than 1,000 times faster than it would run if you're to put normal SQL statements like insert into. If I was to type this directly inside maybe PHP, then it would run maybe 1,000 times slower than it actually runs when I'm using a stored procedure. So what's important for us to note is that we have created our tables, we have created the columns, we have added the data types, we have gone ahead and created relationships and enforced them, and at the same time we have seen how to create stored procedures to help us to be able to populate data into our database. So we're going to carry on with this from next class. I just wanted to introduce it so that during your reading you can be able to figure out more. So as we start delving deep into this, then you already know what the expectation is. So I think with that in mind, that should be sufficient for us to try and see what we need to do. You need to be able to add all the other tables that I've left out, provide the appropriate data type, and even go ahead and enforce relationships. So that is going to be your task for next. You can also look at how these stored procedures work, so that now as we come next time and you're trying to implement them further, you already have an idea of what they are and how they work out. Is there any question at that point? Any question? No question. So if there's no question, it means that everybody is comfortable. So I think that is fine. So I will leave it at that. I'll share this video with you just in case you need to reference what we have done. You can reference that. Then we'll be able to pick this within. So Beth will say you need a practical class. Okay, this is practical enough. I think this is practical, isn't it? Isn't it? This is not theoretical. I think I've demonstrated this, but as I've said, I want to share this video with you so that you can review it as much as possible, so that you are able to add all the other entities that we had provided for. So I'll make this video available on YouTube probably in the next couple of minutes. Then you should be able to get your way around this. Okay? Any other question? All right, so if there's no question, I think we can take a break at that. Then we meet again next time. I don't know when that's going to be, but I think I'll coordinate with your class rep so that we are able to pick this in our next class, okay? All right, no problem. So have a rest, wonderful of the day. We'll meet again next time. I'll share this and give it to your class rep in a few minutes. Thank you and goodbye.